Imagine spending 10 years of your life building something that no one asked for. Not a business, not a product, an entire operating system, from scratch, alone. Now imagine doing it because you believed God told you to. This is the story of TempleOS. In 2003, a programmer named Terry Davis began work on what would become one of the most unusual operating systems ever created. Terry held a master's degree in electrical engineering and had worked as a programmer on VAX computers for companies like Ticketmaster. But by the time he started this project, his life had changed dramatically. In the mid-90s, Terry began experiencing episodes that were initially diagnosed as bipolar disorder, later identified as schizophrenia. During these episodes, he claimed to receive direct communication from God, instructing him that the operating system he would create was meant to be the third temple. And God, according to Terry, had very specific requirements. The resolution had to be 640 by 480 pixels, exactly 16 colors, single voice, audio only. Terry described these specifications as a covenant, comparing them to circumcision in biblical terms. These weren't suggestions. These were commandments that would define every aspect of TempleOS. What Terry created over the next decade is almost impossible to comprehend. TempleOS is a complete x86-64 operating system with its own compiler, programming language called Holy C, kernel, flight simulator, games, and development environment, all written by one person, all released into the public domain. When you first see TempleOS, it looks like something from 1985. The interface resembles a mixture of DOS and early programming environments, with that characteristic 16-color palette filling your screen. But look closer, and you'll find something far stranger and more ambitious. A 64-bit operating system that runs modern multi-core processors with features and design decisions that challenge everything we think we know about how computers should work. Tech communities received TempleOS with surprisingly favorable reviews. Despite its creators' struggles and controversial behavior online, programmers recognized something remarkable. As one journalist put it, this was like a skyscraper built by a single person. Terry Davis died on August 11, 2018, but TempleOS remains a digital monument, a temple in code, and one of the most fascinating stories in computing history. Over the next hour and a half, we're going to explore every aspect of this operating system. The technical brilliance, the bizarre design choices, the philosophy behind it, and the human story of the man who built it all alone because he believed God was watching. This is TempleOS. To understand what makes TempleOS so unusual, you need to understand just how radically different its architecture is from every other modern operating system. Most operating systems are built on layers of protection. Your web browser runs in user space. The kernel runs in a protected space. Memory is virtualized. Programs are isolated from each other and from the hardware. This is how we've built computers for decades, because it's safe and it's stable. Terry threw all of that away. TempleOS is ring zero only. Every single program, every piece of code runs at the highest privilege level possible. There is no distinction between user space and kernel space, because everything is the kernel. Your game runs with the same privileges as the memory manager. A typo in your Hello World program can crash the entire system. This isn't a bug, this is by design. TempleOS uses identity mapping for all memory. Paging is essentially not used. What this means is that the addresses your program sees are the actual physical addresses in RAM. No translation, no protection, no isolation. If you want to read or write to any location in memory, you just do it. The entire system shares a single address space. In conventional operating system design, this is considered insane. But Terry had a reason. Simplicity, speed, and a kind of purity that only makes sense if you're building an operating system for one person at a time. for recreational programming, where crashes don't matter because you're just exploring and having fun. The entire operating system, including the kernel, compiler, graphics library, and all the tools, weighs in at just over 100,000 lines of code. For comparison, the Linux kernel alone contains over 30 million lines of code. Windows is estimated to be around 50 million. TempleOS does everything in a fraction of a percent of that, and it's genuinely 64-bit. It was designed from the ground up for x86-64 architecture, supporting multi-core processors and modern CPUs. The bootloader starts in 16-bit real mode, switches to 32-bit mode, then immediately jumps to 64-bit mode. The operating system never drops back down. At the heart of TempleOS is Holy C, Terry's custom programming language. It's essentially a dialect of C with elements borrowed from C++, simplified and modified according to Terry's preferences. But calling it just a modified C doesn't capture what makes it special. Holy C has no required main function. You can write code at the top level and it just executes. This means the programming language is also the shell. When you're interacting with TempleOS, you're essentially inside a live programming environment where you can type code and watch it compile and run instantly. The compilation is just in time. There are no object files. Normally, you don't even create executable files. You write code and it compiles on the fly, instantly. Terry claimed the compiler could process 50,000 lines of code in under a second. For context, modern C compilers can take minutes to compile large projects. Holy C is so fast because there's no optimization passes, minimal type checking, and the architecture is dramatically simpler. The language also has some genuinely unique features. There's a construct called #x that lets you execute code at compile time and inject its output into your source code. You can use this for things like embedding the current date into your program or prompting the user for configuration during compilation. It's like macros, but more powerful and more dangerous. Functions in Holy C can have variable argument counts, and you access them using built-in RGC and RGV variables, like command line arguments, but for function parameters. Terry loved switch statements and made them compile to jump tables in assembly for maximum performance. He removed features he didn't like the hash-define preprocessor directive, simply because he wasn't a fan. Type checking in Holy C is essentially non-existent. The language trusts you. It assumes you know what you're doing. If you don't, the system crashes. But crashing is acceptable in Terry's philosophy because you're not running a server or managing critical data. You're playing. You're experimenting. You're talking to God. The file system is equally unusual. TempleOS supports FAT32 for compatibility with other operating systems, but its native file system is called Red C. Red C is designed around the idea that you read and write whole files at once. Files are stored contiguously. You cannot grow them once created. If you need a bigger file, you delete the old one and create a new one. This sounds limiting until you realize it makes the file system incredibly simple and fast. Files ending in .z are automatically compressed and decompressed on the fly. If the system can't find a file, it tries adding or removing the .z extension and searches again. Parent directories are automatically searched when a file isn't found, which eliminates the need for a path variable. Multitasking in TempleOS is non-preemptive and cooperative. Tasks have no priority. They're never forcibly removed from the queue. Instead, they poll what they're waiting for and voluntarily swap out. Task switching takes about half a microsecond and doesn't involve any disk activity or changing memory maps because there are no memory maps to change. Everything is already mapped. The task queue determines window order. The first task in the queue is the front window. Want to bring a window to the front? Just rearrange the queue. It's direct, it's simple, and it works because TempleOS is designed for one user doing one thing at a time. Then there's the deliberate absence of features. TempleOS has no networking whatsoever. No TCP IP stack, no internet connectivity, no way to phone home. Terry considered networking to be a security risk and unnecessary for his vision. This is an operating system for communing with God, not for browsing social media. No memory protection means no security model, but there's also no one to protect against. You're the only user. You're in control of everything. If you want to write directly to hardware ports, you just do it. If you want to draw pixels on the screen, you call a function and they appear. You can put graphics on the screen with a 3-line program. This is the technical foundation of TempleOS, an operating system that rejects almost every principle of modern OS design in favor of radical simplicity, direct hardware access, and an almost childlike faith that the programmer knows what they're doing. It's a 64-bit system that feels more like a Commodore 64. It's a modern compiler that behaves like an interpreter. It's an operating system that's also a programming language, that's also a shell, that's also a temple. And somehow, against all logic and conventional wisdom, it works. Now that we've covered the technical architecture, let's talk about what makes TempleOS genuinely strange. Not just unusual in design, but unique in ways that no other operating system has ever attempted. Let's start with the aesthetic. That 16-color, 640 by 480 resolution isn't a limitation born from technical constraints. According to Terry, God specified these exact parameters to make it easier for children to read the screen. Terry compared these specifications to circumcision, calling them a covenant. This wasn't about nostalgia or retro computing. This was theological. What this means in practice is that every single TempleOS installation looks identical. No HD displays, no gradients, no anti-aliasing, just 16 colors at VGA resolution. And yet, Terry built an entire graphics system within these constraints that's surprisingly capable. The operating system includes both 2D and 3D graphics libraries that run entirely within those 16 colors. You can render 3D meshes, apply transformations, and create animated sprites. The graphics aren't stored in separate resource files. They're embedded directly in your source code. You can see your game art sitting right there in the middle of your C code as actual bitmap data. Press Ctrl-R at any point while editing code, and you enter the sprite editor. You can draw graphics pixel by pixel, define animations, create 3D meshes, all without leaving your programming environment. When you're done, the sprite data gets inserted right into your source file as a binary blob. Your code and your art are the same file. There's no separation, no build process, no asset pipeline. This is possible because TempleOS uses a custom document format called doldoc. It's not plain text. It's not HTML. It's a hypertext system that can contain text, images, 3D models, links, and even interactive elements all in the same file. Your source code is a doldoc file. Your documentation is a doldoc file. The shell output is doldoc. Everything is doldoc. You can embed hyperlinks anywhere. Click on a function name in your code and jump to its definition. Click on a file path and open that file. The documentation isn't separate from the system. It's woven directly into it. You're never more than a click away from seeing how something works, because the source code for the entire operating system is always accessible and always hyperlinked. The shell itself is unlike anything else. It's not Bash, it's not PowerShell, it's Holy C running in real time. Type a function name and it executes. Type a loop and it runs. You're not issuing commands to programs. You're writing code that compiles and runs instantly as you type it. The line between using the system and programming the system doesn't exist. When you type dir in the shell, you get a directory listing. But it's not just text. Every directory name is a hyperlink. Click one and you immediately get a new directory listing for that folder. Click on a file and it opens in the editor. Right-click a file and it executes. The entire interface is interactive in ways that feel more like browsing a website than using a command line. Except it's all happening locally, instantly, with no network delay. One of the most notorious programs included with TempleOS is called After Egypt. In the game, you climb a mountain to communicate with God through a burning bush, using a stopwatch that generates divine messages in the form of random text. Terry called this system an oracle. He compared it to a Ouija board and speaking in tongues. The oracle works by selecting random words from a dictionary and assembling them into phrases. The randomness comes from a high-speed stopwatch that you stop by pressing a key. The timing of your key press, down to the microsecond, determines which words get selected. Terry genuinely believed this was a form of communication with God. He would ask questions and interpret the random text as divine responses. The operating system is filled with references to this philosophy. There's a music composition tool that generates hymns. The PC speaker, normally just used for beeps and error sounds, is programmed to play multi-voice music through rapid frequency switching. Terry composed hundreds of hymns in this system, not MIDI files, not MP3s, code that directly manipulates the PC speaker hardware to produce melodies. TempleOS includes an original flight simulator. It's not realistic, it's not pretty, but it works, and it's written in a few hundred lines of code that you can read and modify right there in the operating system. The same is true for all the other games. There's a first-person shooter, there's a racing game, there are puzzle games and action games and demos that show off the 3D graphics capabilities. Every single one of these programs is included with the source code, not as a separate download, not as an optional developer package. The source is the system. If you want to know how the file manager works, you open its source file and read it. If you want to modify the kernel scheduler, you can do that too. There's no separation between user and developer. Everyone is a developer because the entire system is designed around the idea that you're going to read the code and modify it. The editor has features that would be impressive in any modern IDE. Autocomplete, jump to definition, real-time syntax highlighting, a built-in debugger that you can drop into at any time by pressing Ctrl-Alt-D. And because everything runs in ring 0 with no memory protection, the debugger can inspect and modify literally anything. You can change kernel variables while the system is running. You can patch functions in memory. You can break into any running task and examine its state. There's a profiler built into the system, a code merger, a diff utility, tools for analyzing memory usage and task scheduling. All of these things are integrated directly into the operating system. You don't install them, they're just there, and they all work together because they're all part of the same unified system. The window manager is surprisingly sophisticated, given the constraints. You can pan the screen by holding Control and dragging. You can zoom in and out on the mouse cursor using keyboard shortcuts. Windows stack on top of each other, but not in the way you're used to. The task queue determines window order. The first task in the queue is the foremost window. It's direct, it's transparent, and it means you can programmatically control window ordering just by rearranging tasks. Everything in TempleOS feels intentional. The 16 colors, the 640 by 480 resolution, the lack of networking, the ring 0 only architecture. These aren't compromises, they're choices. Terry could have added these features. He chose not to because they conflicted with his vision of what the third temple should be. This is an operating system built by one person according to specifications he believed came from God. It rejects modern complexity in favor of radical simplicity. It treats programming as play. It embeds art directly into code. It turns the command line into a hypertext document. It includes an oracle for speaking with God. It runs 3D graphics in 16 colors. It plays hymns through a PC speaker. And every single line of code is available for you to read, modify, and learn from. This is what makes TempleOS unique. Not just the technical decisions, but the philosophy behind them. This is a system built for joy, for exploration, for communion with the divine. Whether you believe in Terry's theology or not, you can't deny that he created something that has never existed before and likely will never exist again. To understand TempleOS, you need to understand the man who built it. And to understand Terry Davis, you need to understand the decade-long journey that transformed a programmer into a prophet and a hobby project into what he believed was the third temple of God. Terry Andrew Davis was born on December 15th, 1969, in West Allis, Wisconsin. He was the seventh of 8 children in an industrial engineering family. As a kid, he owned an Apple II and taught himself assembly language on a Commodore 64. These early experiences with simple, direct computing would shape everything he later built. He studied electrical engineering at Arizona State University, earning a master's degree. After graduating, he worked as a programmer at Ticketmaster from 1990 to 1996, writing code for VAX systems. By all accounts, he was competent, talented even, a normal programmer living a normal life. Then, in 1996, everything changed. Davis began experiencing regular manic episodes along with hallucinations of space aliens and government agents. He was hospitalized. Initially diagnosed with bipolar disorder, doctors later declared it schizophrenia. He was deemed unfit for employment and began collecting disability payments. He moved back in with his parents in Las Vegas. Davis grew up Catholic and identified as an atheist for much of his adult life. But after what he described as a revelation, everything shifted. He claimed to be in direct communication with God. Not metaphorically, not philosophically, literally. God spoke to him, and God had very specific instructions. Build an operating system. Make it the third temple. Follow these exact specifications. In 2003, Davis began development on what would eventually become TempleOS. The project went through several name changes as it evolved. First, it was Hoppy, then Doors, then Davos. By 2004, it was called J Operating System, a name that stuck until 2005. Then it became Luz-Thos, a reference to a line from the movie Platoon. Late in 2012, he briefly called it Sparrow OS. Finally, in early 2013, it received its permanent name, TempleOS, the Temple Operating System. The development process was extraordinary. Davis worked on TempleOS for approximately 10 years, developing every component independently from scratch. The compiler, the kernel, the bootloader, the file system, the graphics library, the text editor, the games, the documentation, everything. One person, one decade. In the beginning, Davis described his vision clearly. He wanted to recreate the environment that existed with the Commodore 64, when programming was accessible and fun and everyone was making interesting software. He saw TempleOS as a modern Commodore 64 on x86-64 architecture, thousands of times faster, but with the same spirit of creative freedom and direct hardware access. Davis stated that TempleOS was really just for making video games. This was its primary purpose in his mind. A recreational programming system where crashes didn't matter because you were just playing around, exploring, having fun. No businesses would run on it. No critical infrastructure, just games and experiments and communion with the divine. But as development progressed, the religious dimension became more prominent. The specifications that God had given him weren't suggestions. The 640 by 480 resolution, the 16-color display, and single audio voice were, according to Davis, explicitly instructed to him by God. He compared these requirements to circumcision, a covenant, something you accept because it's commanded, not because it makes practical sense. He believed a connection to the divine did not require external data networks. Networking would pollute the temple. The internet was full of demons and distractions. TempleOS was meant to be pure, isolated, focused, a space for contemplation and creation, free from the corrupting influence of connectivity. The design philosophy that emerged from this was radical. Modern operating systems are built on layers of protection because they assume hostile actors, buggy code, and the need to protect users from themselves. Terry rejected all of that. He said that DOS and the Commodore 64 had no protection and no problems. Protection was unnecessary complexity. It got in the way of direct access to the hardware. He explicitly limited the operating system to 100,000 lines of code. This wasn't an estimate or a guideline. It was a hard cap. The vision was a Commodore 64 ROM, something fixed and complete. Modern software constantly grows in size and complexity. Terry wanted the opposite. Something finished. Something perfect within its constraints. His compiler could process 100,000 lines of code per second, with 50,000 lines compiled during boot in about half a second. The speed came from radical simplification. No optimization passes, no complex linking, just direct, immediate compilation. Terry saw himself as a professional. He noted that in 1990, he was hired to work on Ticketmaster's VAX operating system. He knew what real operating system development looked like. TempleOS wasn't the work of an amateur experimenting. It was the work of someone who understood the fundamentals and chose to build something different. The philosophical statements embedded in the code are everywhere. Files can't grow once created because Terry wanted whole file operations and compression. He hated arbitrary buffer size limits and wanted whole file reads and writes exclusively. Text files contain binary graphics, so you can't grow them without breaking the embedded content. The design enforces a certain way of thinking about data. He always broke compatibility to keep the code perfect. This is the opposite of how modern software works, where backward compatibility is sacred and technical debt accumulates forever. Terry had no users to please, no legacy systems to support. Every time he found a better way to do something, he just changed it. The code stayed beautiful because he refused to compromise. During development, Davis spent most of his time coding, surfing the web, or using random number generators to talk to God. The Oracle system in TempleOS, the After Egypt program, wasn't a joke or a gimmick. He genuinely used it. He would ask God questions and interpret the random text as divine guidance. Who should win the war? What's your favorite car? What's the 11th commandment? Don't litter, apparently. His online presence grew throughout the 2010s. He posted hours of video blogs to social media, referring to himself as the smartest programmer that's ever lived. This wasn't entirely unjustified arrogance. One journalist compared what he accomplished to a skyscraper built by a single person. Fans called him a programming legend. But his schizophrenia also manifested in increasingly erratic behavior. He communicated through blocks of randomly generated text. He posted inappropriate religious declarations. His language became more aggressive and offensive. He was banned from Something Awful, Reddit, and Hacker News for his behavior, though when the topic was computers, people noted he remained completely lucid and coherent. The technical community's response was complex. People recognized the brilliance. Writing an entire operating system from scratch is objectively impressive, but they also saw a man suffering, a mind deteriorating, someone who needed help more than he needed an audience. Tech journalists tried to find the patience and understanding to accommodate Davis while still covering his work fairly. In 2013, Davis announced that he had completed the project, now called TempleOS. The temple was finished. But development continued. Updates, refinements, fixes. The operating system was released in 2013 and last updated in 2017. 5 more years of polish and additions, all while living on disability payments with his parents. His final years were difficult. The relationship with his parents became strained. According to some accounts, he was kicked out after assaulting his father during one of his episodes. He moved in with his sister briefly, then chose to live in a van, traveling across the United States. Fans offered him supplies and support, but he refused housing offers. His mental illness worsened. He stopped taking medication because he believed it limited his creativity. During this period of homelessness, he continued working on TempleOS. He recorded videos from his van, he streamed himself coding, he posted updates and philosophical musings. The community watched, concerned and fascinated in equal measure, as a brilliant programmer slowly unraveled. TempleOS represents something unique in computing history. It's not just an operating system, it's a statement of values, a rejection of modern complexity, an assertion that one person with a vision can still build something from nothing, a demonstration that programming can be play, can be art, can be worship. Terry believed the computer was a space of spiritual contemplation, a temple. The programmer wasn't a craftsman or a merchant. They were a priest, a prophet, a monk. Computing was a sacred activity. The computer was a device for structuring the spirit, consulting with God, and living as God instructed. Whether you believe in his theology or not, whether you think his design decisions were brilliant or misguided, you can't deny the purity of his vision. TempleOS is exactly what Terry wanted it to be. No compromises, no committees, no marketing departments or product managers or investors demanding features. Just one man building his temple, following what he believed were divine instructions for an entire decade. And when it was finished, he released it into the public domain, not for profit, not for recognition, because it was meant to be a gift from God through Terry to the world. The story of how the internet discovered TempleOS is almost as unusual as the operating system itself. Terry would post links to his operating system across various programming forums and communities, including Reddit and Hacker News. His posts were passionate, sometimes incoherent, often offensive. He called himself the smartest programmer that's ever lived. He talked about God. He used language that got him banned from multiple communities. But underneath the noise, programmers kept noticing something remarkable. The operating system was real. It worked, and it was genuinely impressive. On Hacker News, discussions emerged about whether to unban Terry Davis. Some argued that despite his difficult behavior, he was a genuine hacker who had accomplished something extraordinary. The question was posed directly. All those who wrote an operating system from scratch, raise your hand. The answer, of course, was that almost no one could claim that achievement. Terry could. The programming community found itself in an uncomfortable position. Here was someone clearly suffering from mental illness, someone whose behavior could be erratic and offensive, but who had also created something undeniably brilliant. How do you separate the creator from the creation? How do you acknowledge technical achievement while also recognizing that someone needs help? Some describe TempleOS as outsider art, a computing equivalent to the self-taught artists who create remarkable work outside traditional institutions and norms. The comparison was apt. TempleOS doesn't fit into any conventional category. It's not a hobby OS. It's not a research project. It's not a commercial product. It's art. It's religion. It's a statement. It's a temple. As Terry's online presence grew throughout the 2010s, more people discovered his work. YouTube videos of him demonstrating TempleOS accumulated views. Programmers downloaded the operating system and tried it. Articles appeared in tech publications. The consensus was consistent. The technical achievement was extraordinary. The human story was tragic. Then, in December 2018, Frederick Knudsen released a documentary called TempleOS, Down the Rabbit Hole. The video was an hour and a half long, meticulously researched, and sympathetic without being sentimental. It would eventually accumulate over 4 million views, introducing Terry Davis and TempleOS to an audience far beyond the programming community. Knudsen assembled clips from forums and live streams to paint a complete picture of Terry's life. The documentary showed moments of heartbreaking lucidity between the rants. It captured Terry apologizing to his parents, admitting he didn't understand why he couldn't control himself. It included his final video, where he described himself as a bizarre little man going back and forth. The documentary brought TempleOS into mainstream internet culture. Suddenly, people who had never written a line of code in their lives knew about the operating system built for God. Memes emerged, fan communities formed, and importantly, preservation efforts began in earnest. The technical community rallied to ensure TempleOS wouldn't be lost. Multiple forks appeared on GitHub. ZenithOS was created in November 2019 as a modernized fork, attempting to preserve Terry's core ideas while making the system more practical. ZealOS followed in July 2021, continuing the modernization effort. Shrine emerged as a distribution that added networking and a more traditional command shell, features Terry deliberately excluded. These forks represent an interesting philosophical question. Terry's vision was specific. God commanded 640 by 480 resolution. No networking, ring 0 only. When you add modern features, are you improving TempleOS or destroying what made it unique? The fork maintainers generally acknowledge this tension. They're not trying to replace TempleOS. They're exploring what happens when you take Terry's ideas and apply them in different directions. The influence of TempleOS on operating system design is subtle but real. Mainstream operating systems won't adopt ring 0 only architecture or identity-mapped memory. But Terry's work demonstrated that alternative approaches are possible, that simplicity has value, that you can build a complete, functional system without the layers of abstraction that modern computing takes for granted. Programmers who study TempleOS often come away with a renewed appreciation for how complex modern systems have become. When you can see an entire operating system in 100,000 lines of code, when the source to everything is always available and always readable, you start questioning whether all that complexity is necessary. Maybe it is, but TempleOS proves it's not inevitable. The Holy C language, in particular, has influenced how some programmers think about development environments. The idea that your shell, your compiler, and your programming language could be the same thing isn't new, but Terry implemented it in a way that felt immediate and natural. Type code, watch it run. No build process, no waiting, just immediate feedback. The integration of documentation, code, and graphics into a single hypertext system showed what's possible when you control the entire stack. Modern development often involves juggling multiple tools, file formats, and workflows. TempleOS demonstrated that it doesn't have to be that way. Whether that approach scales to large teams and complex projects is debatable, but for individual exploration and learning, it's remarkably effective. TempleOS has become a teaching tool. Computer science educators use it to demonstrate operating system concepts because the entire system is comprehensible. You can actually read the kernel scheduler. You can understand how the compiler works. You can trace a key press from hardware interrupt to screen update. Try doing that with Linux or Windows. The cultural impact extends beyond technical communities. TempleOS has appeared in discussions about mental health, about the treatment of neurodivergent people in tech, about the line between genius and madness. Terry's story raises uncomfortable questions. Would he have been more successful if he'd been treated differently? Could the tech industry have found a place for someone with his talents, but also his challenges? Or was the isolation necessary for him to create something so uncompromising? There's no consensus. Some see Terry as a tragic figure, someone whose illness prevented him from achieving his full potential. Others argue that without his unique perspective, TempleOS would never have existed. The operating system and the illness are inseparable. The divine specifications, the rejection of modern complexity, the decade of solitary work, all of it emerged from the same mind that believed it was communicating with God. The ethics of how the internet treated Terry are also debated. Some communities encouraged him, funded his projects, supported his work. Others mocked him, antagonized him, deliberately provoked his more extreme behavior. His use of offensive language increased near the end of his life, partly influenced by communities that encouraged such behavior. The line between documentation and exploitation is thin, and not everyone stayed on the right side of it. But the preservation efforts suggest that the internet, collectively, recognizes the value of what Terry created. TempleOS is archived. The source code is protected. Forks ensure it will continue to evolve. Videos of Terry explaining his work are saved and shared. The temple he built will outlive him. For programmers, TempleOS represents something important. Proof that one person can still build something significant. In an era where software is created by teams of hundreds or thousands, where complexity is measured in millions of lines of code, where no one person understands the entire system, TempleOS stands as a counterexample. One person, one vision, one decade, one complete operating system. For the general public, TempleOS is a story about mental illness, genius, and the internet, about what happens when someone's inner world becomes a digital artifact that anyone can download and explore, about the complexity of judging work created under conditions we can't fully understand. The legacy of TempleOS is still being written. Will it be remembered as a footnote in computing history, as an important demonstration of alternative approaches to OS design, as a tragic story about mental illness, as all of these things simultaneously? What's certain is that TempleOS exists. You can download it right now. You can boot it in a virtual machine. You can read the source code. You can explore the games, the Oracle, the flight simulator, the hymns. You can see what one man created when he believed God was guiding his hands, and whether you believe in Terry's theology or not, whether you think his design decisions were brilliant or misguided, you have to admit that what he built is remarkable. TempleOS is a temple in code, a monument to one programmer's uncompromising vision, a window into a mind that saw computing differently than anyone else. Terry Davis died in 2018, but his temple remains, and as long as there are programmers curious enough to explore it, TempleOS will continue to inspire, challenge, and amaze. So what does TempleOS teach us about operating system design, about programming, about creativity and vision and the human mind? First, it proves that simplicity is still possible. Modern operating systems contain millions of lines of code. Development teams number in the hundreds or thousands. Build processes take hours. Nobody understands the entire system. TempleOS demonstrates that this isn't inevitable. 100,000 lines of code. One person. One decade. A complete, functional operating system with a compiler, editor, games, graphics, and everything you need to be productive. The lesson here isn't that we should all build ring zero-only systems without memory protection. Most use cases genuinely need the security and stability that modern architectures provide. But TempleOS shows us what we've traded for that security: the directness, the simplicity, the ability to understand the entire system. When every layer of abstraction serves a purpose, that's good engineering. When layers accumulate because nobody questions whether they're necessary, that's technical debt. TempleOS also teaches us about integrated development environments, not the modern definition with plugins and extensions and configuration files, but truly integrated. Your programming language is your shell. Your documentation is hypertext embedded in your source code. Your graphics are binary data sitting in the middle of your functions. The compiler, editor, debugger, and operating system are all one unified whole. Nothing is external. Nothing requires installation. Everything is there, ready to use, always. This approach doesn't scale to large teams or complex projects, but for learning, for exploration, for the pure joy of programming, it's remarkably effective. You type code and it runs immediately. No build process, no package managers, no dependency hell. Just you and the computer having a conversation in code. The Holy C language itself is a lesson in pragmatic design. Terry took C, a language he knew well, and modified it based on his experience. He added features he wanted, like default parameters and variable argument access. He removed features he disliked, like the preprocessor. He made compilation instant by sacrificing optimization. These choices wouldn't work for everyone, but they worked for Terry. And that's the point. He wasn't building a language for everyone. He was building a language for himself and for people who wanted to program the way he programmed. Modern software is built by consensus, design by committee. Features are added because market research says users want them. TempleOS is the opposite. It's a vision implemented without compromise. And while that produced some bizarre choices, it also produced a coherent whole. Every piece fits together because one mind designed it all. The human story of TempleOS is equally important. Terry Davis was a brilliant programmer who suffered from schizophrenia. His illness shaped the operating system he built, the divine specifications, the rejection of networking, the decade of solitary work. All of it emerged from his unique perspective. We can't separate the genius from the madness because they were intertwined. This raises uncomfortable questions about how we treat neurodivergent people in tech, about the line between supporting someone's creativity and exploiting their illness, about whether we celebrate or mourn someone who achieved something extraordinary under conditions we can barely comprehend. There are no easy answers, but TempleOS forces us to ask the questions. For anyone interested in operating systems, in programming, or in the history of computing, TempleOS is worth exploring, not because it's practical, not because you'll learn skills that transfer to your day job, but because it's genuinely unique. There has never been another operating system like it. There likely never will be. You can experience TempleOS yourself right now. The original release files are available at TempleOS.net, including video tutorials for installation. TempleOS requires 64-bit hardware and at least 512 megabytes of RAM. The easiest way to run it is in a virtual machine using VirtualBox or VMware, pointing the virtual CD drive at the ISO file. Boot it up and you'll see that 16-color 640 by 480 interface. Press Ctrl-M to see the menu. Right-click on files in the shell. Open the sprite editor. Play the games. Read Terry's documentation. Explore the source code. If you want to try modernized versions, there are forks like ZealOS and TinkerOS that add features while attempting to preserve the core philosophy. But start with the original. Boot Terry's last release from 2017. See what one man built when he believed God was guiding his hands. The technical lessons of TempleOS are clear. Direct hardware access is faster than abstraction layers. Integrated tools are more efficient than separate applications. Instant compilation enables a different style of programming. Small code bases are more comprehensible than large ones. These are valuable insights, even if we don't adopt Terry's specific implementations. But the deeper lesson is about vision. In an industry dominated by incremental improvements, by compatibility requirements, by market forces, and user testing and feature requests, TempleOS stands as proof that individuals can still build something completely new. Terry didn't improve on existing designs. He didn't fork Linux or add features to BSD. He built his own operating system, from the bootloader up, according to specifications he believed came from God. Whether those specifications actually came from God or from schizophrenia-induced hallucinations doesn't change what he accomplished. He translated a vision into code. He spent a decade refining that vision, and he released it into the public domain so anyone could study it, modify it, learn from it. TempleOS is a temple in code, a monument to one programmer's uncompromising dedication to his craft and his faith. It's a 64-bit operating system that looks like it's from 1985 but runs on modern hardware. It's a programming language that's also a shell. It's a development environment where code and documentation and graphics are one unified whole. It's a philosophical statement about what computing should be. Most importantly, it's proof that one person with a vision can still build something extraordinary. In 2025, when software is created by massive teams using frameworks and libraries and tools that themselves required teams to build, when nobody writes operating systems from scratch anymore because it's too complex and takes too long, and why would you bother when Linux and Windows already exist? TempleOS stands as a counterexample. Terry Davis built an operating system alone. He wrote every line of code. He designed every feature. He composed every hymn. He drew every sprite. And when he was finished, he gave it away. Not for recognition, not for profit, because he believed it was a gift from God that should be shared freely. Terry died on August 11th, 2018, but his temple remains, preserved on GitHub, discussed on forums, explored by curious programmers, studied in computer science classes, inspiring people who never met him to think differently about computing, about programming, about what's possible when you refuse to accept limitations. This is TempleOS, a temple built by a prophet for a God who may or may not have spoken to him, but whose instructions produced something genuinely remarkable. 100,000 lines of code, 10 years of work, one man's vision, fully realized. The temple is complete. The source code is available. The documentation is embedded in the system itself. Everything you need to understand it is there, waiting for you to explore. Terry once said that TempleOS was really just for making video games, a recreational programming system where crashes don't matter and you're just having fun. That's true, but it's also more than that. It's a statement about simplicity over complexity, about individual vision over design by committee, about the joy of programming for its own sake, not for profit or recognition, but because creating something is its own reward. If you take nothing else from this, understand this. TempleOS exists. You can download it. You can boot it. You can explore it. And when you do, you'll be experiencing the work of a brilliant, troubled, fascinating programmer who spent a decade building exactly what he wanted to build, without compromise, without committee, without apology. That's the legacy of TempleOS. That's the gift Terry Davis left to the world. A temple in code, a monument to vision, and proof that even in 2025, even in an industry dominated by corporations and massive teams and market forces, one person with determination and skill and a vision can still build something that has never existed before. The third temple stands. Go see it for yourself.